Ever since the launch of Terran 1, Relativity Space has shifted its complete focus to Terran R, a much larger, reusable 3D printed rocket. For months now, we have seen work on new manufacturing facilities, test sites, and actual rocket hardware. This includes brand new testing and the first full static fire of the vehicle's Aeon R engine. Just yesterday, the company released footage of the engine firing and provided updates on its progress. In the future, 13 of these engines will power Terran R and are necessary when determining the efficiency, reliability, and reuse opportunities of this next-generation rocket. Something Relativity is taking very seriously and needs to get right in order to have success in the future. Here I'll go more in depth into the new static fire, how Aeon R got to this stage, other Terran R developments, and more. Starting earlier this month, we got a hint that a big test was about to happen when the company tweeted saying, "First look, Aeon R on the test stand." This included an image of the engine rigged up and practically ready to fire. Only a few weeks later, on the 14th, the company announced that they had completed the static fire and the results were promising. In total, it was a 10-second fire. However, they pointed out that the test validated component harmony during startup at a target power of around 70% and shutdown. They were also quoted saying, "Strong start to the test campaign. Initial hardware inspections look healthy. Longer duration, more power, more blue fire." What makes this test especially interesting is the fact that the engine is 3D printed. Relativity believes that by using 3D printing techniques, they're able to design more function into the engines, with less material for less cost. They also have some history building the Aeon 1 engine for Terran 1, which they've learned a lot from. This being said, the engines are very different. To put it in perspective, a single Aeon R engine has 25% more thrust than all 9 Aeon 1 engines combined. The significant size and power increase mean teams at Relativity are facing a lot of new challenges. Since mid-2022, Relativity has been underway testing all Aeon R combustion devices at NASA's Stennis Space Center, including the main thrust chamber assembly, or TCA, the gas generator, or GG, and gas-gas ignition system, at full scale and 100% power with high combustion efficiency. All engine active valves are developed in-house, with all valves produced, successfully actuated, and in development testing. The Aeon R produces a sea-level thrust of 258,000 pound-force and a combined vehicle liftoff thrust of 3,354,000 pound-force. Looking at images of it next to Aeon 1 in humans helps put its size and power in perspective. At its core, Terran R's 3D printed Aeon R engines are designed to use liquid oxygen and liquid methane propellants, be highly reusable, and feature a uniquely high-pressure gas generator cycle driving 2 turbopumps. The company is quoted saying, "Designed and manufactured in-house by Relativity, Aeon R engines are produced with significant advancements in additive manufacturing technology, building on the development of the company's prior engine, Aeon 1. These new 3D printing capabilities enable the scale required for the higher thrust class Aeon R engine, continuing to drive part count reductions by designing and printing singular nodes of simplicity, streamlining many engine elements into unified prints. This innovative design approach supports lowered costs, lowered engine complexity, greater robustness, rapid iteration, and the speed and scale of production required to serve customers," they said. The company is obviously very confident in both the engine's design and the manufacturing techniques being used. At the same time, they're making physical progress quite quickly, which helps their case. Focusing back on the static fire, there's still a lot of work necessary to perfect this process and prepare for full duration fires. With the booster expected to be reused 10 plus times, the engines need to work again and again and require little to no refurbishment between missions. Standing at 270 feet or 82 meters tall with an 18-foot or 5.5 meter diameter and a 5 meter payload fairing, Terran R is going to be a massive rocket. This large jump from the much smaller, expendable Terran 1 to a reusable giant like Terran R is extremely ambitious. It's also why Relativity has been all hands on deck building new 3D printers, facilities, test stands, etc., all to get ready for the future of this rocket. For example, the company recently got access to the A2 test stand and has been working to revamp and prepare it. This is going to be a large overhaul and is meant for future Terran R testing. Over on the launch site, specifically Space Launch Complex 16 in Cape Canaveral, Florida, demo work is underway for land clearing of Terran R's new propellant farm and future launch pad. Even in Stennis, the company is in the process of building and constructing massive test stands and propellant farms all for this next-generation vehicle. As of right now, Relativity believes they can launch Terran R for the first time in 2026. This has moved back a decent bit from past estimates, but is still not far away, especially considering the work that still needs to be done. Taking a closer look at the rocket, they describe Terran R as a customer-centric next-generation launch vehicle designed to meet the needs of commercial companies and government entities sending payloads into LEO, MEO, GEO, and beyond. The vehicle's architecture choices are meant to enable accelerated development and the ability to deliver a rapidly scaling launch cadence for customers. As far as reusability goes, Terran R will prioritize first stage reuse, with the capability of launching 23,500 kilograms to low Earth orbit, or 5,500 kilograms to a geosynchronous transfer orbit, both with a downrange landing, or up to a maximum payload capacity of 33,500 kilograms to LEO in an expendable configuration. Most uniquely, Terran R is a 3D printed rocket, with initial versions using aluminum alloy tank straight section barrels in a hybrid manufacturing approach, which the company says allows them to meet the rapid launch and ramp rate timelines necessary to serve overwhelming market demand. By now, Relativity has a total of 9 signed customers for Terran R, including multiple launches, totaling more than $1.8 billion in backlog. This funding and support have helped the company build and expand at such a rapid pace. While they have experience with Terran 1, each Terran R requires approximately 6 times more 3D printing by mass than that smaller vehicle. Initially, Terran R will use the same proprietary printed aluminum alloy as flown on Terran 1, with a focus on supply chain scaling. However, a third-generation aluminum alloy designed for improved performance of an orbital vehicle mission life beyond 20 reusable flights is in active development, which they say is accelerated by the aid of artificial intelligence-based alloy discovery tools. The plan for first-stage reuse will also be somewhat similar to other rockets within the industry. As partially mentioned prior, Terran R's first stage will be outfitted with 13 3D-printed gas generator Aeon R LOX/methane rocket engines, while its second stage houses a single LOX/methane Aeon vac engine. The specific engine composition on the first stage is comprised of 4 outer fixed engines aligned underneath 4 landing legs, and 9 center gimbaled engines, providing enhanced reliability on vehicle ascent with engine-out capability. Subcooled cryogenic propellants are used on all parts of the vehicle except for the first stage liquid oxygen system, where subcooling is not necessary to meet performance goals. Both stages use a cryogenic helium pressurization system to enable better press authority when engines are not turned on. The vehicle also features an in-house developed pneumatic pusher stage separation system. In addition to the landing legs and gimbaled engines, Terran R features 2 near-body length aerostrakes and 4 printed actuated grid fins. These features, among others, are meant to allow the first stage architecture to have a high angle of attack reentry, which reduces propellant required for reentry burns, aerodynamic design for better reentry stability and improved control authority, and a passively actuated landing leg deployment system which they describe as elegantly simple, lightweight, and highly operable for rapid reuse. An 18-foot vehicle diameter also aids vehicle stability with lower requirements on landing legs, all of which we could see in use in just a few years from now. Relativity Space just completed its first static fire of Terran R's new Aeon R engine. While short, it's a great first step and an important milestone in the project's overall timeline. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.